Hey, welcome to episode 7 of Unlocking the Vault with Dan Linstedt. I'm your host, Cindi Meyersohn. We will be picking up from episode 6, focusing on what does the methodology, the architecture, and the data vault standards have to do with the business? Aren't these just technical things? Why should the business care, Dan?
The business should care because they care about the investment they're making. At the end of the day, what good does a business user have? Why would they want to put money into something they know not going to work? So at the end of the day, they want ROI like everybody else, the ROI, return on investment. And oh, by the way, we just started a glossary on the learn.datavaultalliance.com site. And we only have 2 terms out there today, but we're going to add a bunch, including things like ROI and so on and so forth. And as you see them pop up on the websites, you're going to see them underlined and highlighted both on learn.datavaultalliance.com and datavaultalliance.com. But we're not there yet, so bear with us. All right. So back to the question at hand. Why should the business care? Well, like everything else, the business is in business to make money, not burn money or lose money. The same goes for you at home. If you're sitting in your house and you spend money on something, let's say you buy a piece of furniture, you don't use it, and then you throw it out like a year later, you just burned the money. But if you resell the furniture, maybe you get a little bit of money back. And obviously it devalues over time. If it's well loved, well used, and it's creaky and has problems, well, then that's an issue, right? But that's for furniture. I guess the same analogy can go for systems. If you don't maintain the systems or the solutions, if you don't continuously improve the solutions, then you're going to lose money. But the business should care about the cost of the solution build. The business should care about the results, getting results from the IT team, being able to measure cost versus results or actuals versus estimates and all those other things. The business should care about reducing the IT delivery times. Now, I say business should care, and I can see IT people and especially IT leaders shaking their heads. What you didn't hear was what was most important. IT is a business. The leaders of IT understand this. Some of the technical people don't. It's unfortunate, but it's time to learn. IT needs to act like a business, walk like a business, talk like a business, be managed like a business, be held accountability like a business unit. It is a business unit. It just so happens that this business unit has technical skills and delivers software and solutions. So it needs to be treated like a business, but it's time for IT to, quote, grow up. In order to grow up, it needs to really say, hey, look, my estimates are valuable and valid. We perform on time and in budget. And this is what I mean by business needs to care about reduction of IT delivery times. It's both the business users, the business analysts, as well as the IT and the business side of the management side of IT that are driving the business forward. I think how the data is as an asset on the books is important. Understanding the KPAs and the KPIs and how the solution is meeting those or not meeting those, that's important. We talked about KPAs and KPIs in one of the previous podcasts. Being able to measure what you build, being able to identify what you build, being able to improve and optimize what you build. Those are all valuable constructs and make it better, faster, cheaper, which is the shortened way of saying that. And then corroboration with IT. Well, wait a minute now. It's really corroboration with business. It is business to business. And again, it just so happens our business is technical. So that's where IT comes in. But providing greater value to insights, because I can flip around as a business analyst and say, well, if IT doesn't deliver on time, I still have a management answer to provide. So I'm going to do it by hook or by crook. I'm going to create a shadow organization. I'm going to do it myself. I'm going to put it in Excel or Access database. God help me, right? It's going to end up somewhere where IT can't manage it. And then the cost will spiral out of control, or it's a one and done solution, or it costs the business every week. I run this algorithm. I spend 4 hours on it as a business analyst, and I'm 4 times more expensive than spending the money once in IT to get it built into an automated pattern or something like that. So these are some of the things that the business needs to care about.
When we talk about Data Vault, again, we were alluding to a couple things during episode 6, where we were talking about Data Vault concepts from the modeling perspective and how there are other modeling concepts out there. I have heard from time and again on the business side where the argument is, well, what is the difference between a data vault and say a Kimball or a star schema? How do you compare the two? If I'm a business, I'm trying to make a decision and IT is presenting to me these different modeling concepts or techniques or methods. How, as a business, can I understand what some of these differences are? With those differences, are there holes that introduce risk to my business if my team goes down those analytic paths?
It's an interesting thought. And I'm often asked to run comparisons, and I have been for the last 22 years. I've written quite a bit on the web publicly about this. So if you really want to go find it, you can Google it. It's all out there. If you want some links to some of the stuff I've written, then please ask us and we'll share those links with you. There are a lot of other people that have written things, and some of those things out there are inaccurate. One of the very first questions that you might be faced with as a business person, a sponsor, is this idea that Data Vault can be compared with Kimball Bus. Or you may have heard, hey, let's compare Kimball Star Schema with Data Vault. Or maybe you heard, let's compare Kimball with Data Vault. These are all basically inaccurate comparisons. If you try to compare a 50-story high-rise building, a huge office complex taking up a New York City block, with a single-family residential home, 1,500 square feet, that's an inaccurate comparison to some degree, because in the analogy, they both have a model. What is the model? The model are the blueprints. The blueprints for the high-rise, you have this thing called blueprints for the high-rise, which define where the electrical goes, where the elevators go, the plumbing goes, the concrete goes, the supports go, the whole 9 yards, how big each floor is, how high the ceilings are, the whole thing. Yeah, and you have blueprints for a single-family home at 1,500 square feet, whether it's a 2-story or a walkout basement or a single level or a multi-level and so on and so forth. Blueprints are blueprints. You can compare blueprints to blueprints. But would you really want to compare a high-rise, a set of blueprints for a high-rise building to a set of blueprints for a house, a single-family home? Probably not. It's inaccurate within context. So that's the problem there. When you talk about Kimball Bus, you're talking about Kimball Bus architecture. And that's an architecture that defines where you put different components. The right comparison is Kimball Bus architecture to Data Vault architecture. So if you attach the right label to the right place, then you can do an accurate comparison. So that is accurate. The Kimball Bus architecture only has 2 layers. It has a staging layer and it has what they call a federated star schema layer, which is a conformed dimension layer. It's what they call the enterprise data warehouse or the logical data warehouse. And it really isn't an enterprise data warehouse, but those are some of the labels that you hear. The other thing that you hear is Kimball Star Schema. Well, let's compare apples to apples. A star schema is a data model. So when you're going to compare that, you have to compare that with a data vault model. And I want to take you back just for a minute. The origins of the star schema were meant for drill down. They were designed as a fact and a dimension table that never had any history. So it didn't have year over year or last week or it was always current. It was meant for pivot tables. Exactly the same way you would treat an Excel spreadsheet with columns across the top, headers, and columns across the side or the left side, again, more headers or divisions of data and the data in the middle. It was meant for drill-in analysis. The original design of the modeling techniques were never meant to be an enterprise data warehouse holding history over time. So what happened? Well, Kimball did a good job. He looked around and he said, we need something to solve an analytical set of problems. We don't have anything. The other method of modeling for a data warehouse just don't work. So he went in, and I got to give him kudos. He went in and took a star schema design and said, well, this is easy to understand. And he added time or temporality to it. In other words, history. So there are some comparisons, but the difference there is that the business decided to change data on the way in. Let's brush under the rug all of the technical problems and the bad data quality problems. Let's fix it and munge it and correct it on the way into the star schema and come up with this, quote, single version of the truth, which we don't subscribe to. That was fine for the first 2 or 3 iterations, the first 3 to 6 months or 9 months. Eventually that fell down. It became brittle. and it added complexity to the loads. And every time IT or business turned around and said, hey, add this piece to my star schema or my Kimball architecture, IT would go away and come back with longer and longer estimates to add it in, to integrate it. And the reason was they had to re-engineer all of the previous load cycles and all of the business rules that were affected or impacted by the business request for change. Eventually, the business said, this takes too long. It costs too much. So let's greenfield it. Let's shut it down and build it all over again, start it from scratch, and we should be able to build it right this time. But y'all have heard, the definition of insanity: do the same thing over and over again, try to get a different result, and that doesn't work. That's the comparison with the Kimball. Now, to move on to the Inmon stuff, a lot of people say, well, let's compare Data Vault to Inmon. And first off, that's completely inaccurate. Bill Inmon took what is called third normal form or a normalized form. And in business speak, we call that operational data modeling. So that's for your operational systems, your PeopleSoft and your Oracle Financials and your i2s and your JD Edwards and all that other stuff of the world. That's operational transactional processing. And that's how we house the data in that. We just happen to call it third normal form. And there's a whole slew of acronyms around that, which we won't get into here. So Bill took, and Bill's a good friend of mine, by the way. I got to give a shout out to him. He supports the Data Vault, in case you didn't know. But at the time, he did this in the 70s, long before I came along. And what he did was he said, well, we need to add temporality to the normalized formats of operational modeling so we can house history. And that posed a whole set of other design time problems based on the original modeling architectures. However, Bill's ideas around enterprise analytics are extremely sound and still in use around the world today. They're extremely valid. No validity is lost on, quote unquote, the Inmon data warehouse. In fact, the Data Vault supports the Inmon data warehouse as the formal definition of what a data warehouse should be. We just happen to use a slightly different type of modeling system for how that works. So imagine if you tried to use, and here's the analogy side of it, if you tried to use a single family home, 1,500 square foot ranch style blueprint to go and build a 50-story high-rise building, what kind of result would you come up with if you adapted that blueprint to do something it wasn't meant to do? And so sort of this is where the Kimball bus star schema models started to fall down. This is where the Inmon data warehouse and data modeling aspects of it specifically started to fall down. And this is where the Data Vault model came in and said, well, you know what? And some people say, well, Data Vault model, what is it? I'm just going to tell you, from a business perspective, it's a hybrid of both approaches. I looked at Kimball and I said, what works? What's good about it? What works? What can we use from that piece? And I took those pieces, and then I looked at operational modeling, which had been around since since data was invented and computers were invented. They started working on, since Cod and Date originally defined the different forms of operational modeling. And there's a lot of good things there. Again, I stand on the shoulders of giants. So I took what works from the operational side. I took what works from the Kimball side, and I said, oh, these are great ideas. Let's combine them in a different way. Let's rebuild this thing. We've never built one of these buildings before. Let's build a new blueprint pattern for a completely different style of building. And that's really what the Data Vault model is about. But in terms of the architecture, we landed with the Inmon style of architectural design, which basically said you have a staging area, then you have a raw warehouse, and then you have the information marts. Now, since then, we've expanded it. We've included some business layers and some transformation layers and so on and so forth. It doesn't mean that the data keeps moving. So we try to virtualize as much as possible. We try not to move the data when we don't need to. We can use virtualization engines and data wrangling engines and BI engines and on and on and on. So there's lots of techniques to mitigate moving the data physically. And these days, if you're in the cloud with Snowflake, you might not even have to move it out of a, quote, staging area, although that's debatable. That's a discussion for the future. That's sort of a roundabout comparison with some of the other things that Data Vault gets compared with. Again, it's built for purpose. The Data Vault model is designed with the best practices from both sides of the fence in mind. So it's important to remember this, because it isn't really, quote unquote, can't look at it and say, oh, well, that's all completely new, because that's not. There are elements that are found in type 2 dimensions. There are elements that are found in third normal form. There are elements, and this is about as technical as we're going to get. You can do research and you can find out how all this basically comes together. All right, so let's move along and talk about how did the data vault model get built from a business perspective? We spend a lot of time talking about the data vault model, the data vault model, the data vault model. And I mentioned in the last podcast that modeling alone is not enough. And that's true. However, would you build a 50-story high-rise building without a blueprint? If you said yes to that question, then you're asking for trouble right from the start, from the time you break ground, because you've got no measurements, you've got no containers, you've got no scope on your project. You don't know where to run the wires. You don't know where the load-bearing walls should be or the pillars should be. And chances of you actually succeeding in building a 50-story high-rise are slim to none. So a model is an integral part of a successful solution. So we do want to talk about the data vault model and why it got built and how it got built and why is it structured the way it is. But we're going to do that from the business perspective. So the very first thing is separation of concerns. What I mean by that is when you look at a business, again, to go back to the Lockheed story, and you start thinking, well, they're divided into sectors. You've got astronautics, aeronautics, electronics, and on and on and on. Each sector cares about its own data, its own production, and its own ROI, and on and on and on. The sector's divided into companies, but within the company and across the companies. So inside of aeronautics, for example, where they build airplanes, across the multiple companies within the aeronautics sector, they all care about this thing called an airplane. Got wings, it flies, it hovers, sometimes like Harrier jets and so on. So how do you separate business concerns? Well, you not only have the aircraft, which is the product you're building, but you have the contract, which is the data about the product you're building. The contract is a vehicle. It may be digital, it may be on paper, it may be both. But you need to track the contract as much as you need to track the build process of the physical real world thing. Separation of concerns. And then to go a little bit further, not only do you care about the aircraft, but you have to decompose the aircraft because an aircraft is a complex piece of machinery. You don't just build a sand model, dump in some metal, and then out comes an aircraft and it flies. It doesn't work that way. You can't simplify the process down to the point that an aircraft is all one part. It's broken into hundreds or thousands of different parts that all fit together, that all work together. It's a complex piece of machinery that must be engineered. So now you're talking about a contract to build with hundreds or hundreds of thousands of parts, all in the bill of materials, planning bill of materials, the manufacturing bill of materials. And each part is tracked by a part number, a model number, a unit number, and so on. So you've got these different keys, these different business keys for tracking this different data across multiple companies, across a complex build process. Sometimes it's 6-month build, sometimes it's a year-long build, sometimes it's a multi-year build. And you get suppliers that come in and out of business and that you have to contract with for building certain parts and so on. So how do you track this whole thing from end to end? And then on top of that, you've got the executive concerns. How do you know you're doing it better? So you build this jet 15 times. How do you know you saved money by changing the business? So if you change the business next year, how do you know if that business decision was a good one or a bad one? We started with separation of concerns, but then the focus grew into business keys, business concepts, as I was just mentioning. We have to be able to track the data through the systems and at the same time, tie the data to the business. You have to take the data that's in the operational systems at any point in any one of the operational systems and be able to point at it and say, I know where that fits in the master data scheme of world. In the view at the executive level, I know that this is the same contract, even though it has a different contract number as this contract over here in this system. Those two are the same contracts. These are questions that the business wants to know. So the data vault model is focused on these business concepts, and this is what it was born to do. We happen to call this thing a business key. And then from the physical aspect, in the technical sense, we build it into a table called a hub, a location, an area. It's a center point for your concept. It's called a hub. But then if you think about it, it's not enough to have a key. You have a key to your car, there's some number stamped on it. And if you were just handed a key to a car with a number stamped on it, what do you know about the car? If it's your key and you know your car is sitting in the garage, you know a whole lot about the car. You know what color it is, how many doors it has, whether it's got a sunroof. What if it's not your car? What if you are a person that unloads cars from a container ship and you're handed a key, go find this car? You're not given any context. No one tells you what color, what make, what model, what year. No one tells you where to find it. There's 15 decks on some of these ships. They're hundreds of yards long. How do you find the car with this one key in order to move it off the container ship? This is the problem. So you need context, and these are descriptors. So the color of the car, the number of doors, the size of the engine, on and on and on. These are all context elements, and they can change. If you paint your car, you change the color. That doesn't mean you change the car. So the car has a VIN number, vehicle identification number. That's the concept. So what I'm getting at is the data vault model is geared, when it's built properly, to address these concepts in business at the business level. We then surround the keys with context, but then there's one more piece. You are a driver. You have a driver's license. You are the owner, registered owner of this car. How is there an association between you today and this car today? Because tomorrow you might sell that car. You are no longer the owner of that car. So there's a timeline at which you were active or an active owner of that car. But more importantly, there's a relationship between you, your driver's license specifically, which identifies you with a number, and the car, which is identified in the Department of Motor Vehicles by a VIN number. This is a relationship, a business relationship. And so we call these things links. We also call them associations. They're business-based associations. And so using this model of decomposing a business concept into descriptions, identifiers or business keys, and associations, we can build a modular pattern that's repeatable and scalable, and helps reduce risk because we can downscope it. And by downscope it, I'm talking about the IT effort to build this. We can downscope it to a simple set of products and say, okay, we're going to break this data down into one business key, one set of descriptors, might be 2 or 3 quote unquote tables or ideas, and then one association. And we can run that all the way through and push it out on the other side in a BI window or a BIQ and make it available to a dashboard. That's what I mean by downscope. We can get to one single business concept, and we can work with 1, 2, or 3 different source systems that provide that data. And so this is where we start to talk about repeatable consistency and patterns. And Cindi, I know you've done a lot of work with data vaults. What are your thoughts on this?
Well, we were talking in the previous episode about business approach of, we're really excited about our data warehouse. Now give us all the data. That's everyone's nightmare, right? But this is one of the areas that was so attractive about Data Vault, was the idea that it is people, process, and technology. And it is about the business. And so the ability to scope, as you mentioned earlier, this modular design, we don't actually have to load all the data. That is not the goal. The goal is to build, based on business focus, these concepts that can be added to over time. We often talk about the way a data vault grows organically. And we talk about, you were mentioning Bill Inmon's third normal form model. We often look at it and we say, wow, that's deep. In other words, there's a lot of layers. There's a lot of interconnects on a technical side of a third normal form construct, which brings with it cascading impact when changes are made, when the business needs to pivot on certain aspects of their data and or data relationships, if you will, as you were talking before. The business needs to pivot, and now the model in your data warehouse has to now pivot, and the cost to that, that's all part of technical debt. And how do you build resilience? Because that's important to the business, not only that you can pivot quickly, but the impact of that pivot is not a huge cost in both time and money and investment. So this idea of being able to build something out organically by sort of adding to a data vault, where a data vault grows horizontally in size versus vertically in size, which is that deep connection we get through cascading relationships and things in a third normal form or Inmon type of structure. So from a business, I always felt when it comes to being able to very quickly pivot, whether that pivot means we are going to pull in a completely different data source that contains data elements that are part of a concept, a business concept that we've already modeled, it makes it quite scalable because we already have the concept designed, partially loaded, and then we have this new data set that comes in that we're only having to make a small adjustment for, and that's maybe just simply building a construct to hold that context around that concept versus having to build a whole new set of structures. And so from my perspective, that was the whole, how do you deal with, we're not going to boil the ocean, but let's deliver something that is of business value to you that is also highly resilient and scalable so that we can start reducing the cost, not increasing the cost to the business. So that's sort of where I come from when you talk about scalability, modular design, and why I think it is so critical that the business has an understanding of the foundation that they're building, the importance that that foundation is capable of absorbing change, of pivoting on change without having to re-engineer and pour more cost and expense into it.
In terms of this, one of the things is re-engineering. I just want to go back to this. When you talk about a Kimball style star schema, federated star schema as an enterprise data warehouse, you start talking about re-engineering. It's very similar to building a 50-story high rise. And then someone says, well, I didn't want a 1-block radius. I wanted a 2-block radius or a 2-block footprint. You can't just go back and build up another high rise that spans 2 blocks and wrap it around the building that's already there. I mean, some people would argue with me that you can do that and you can build the 2 buildings separately, but that's tremendous cost. In the digital world, in an enterprise world, in the data world, you have to actually invest in re-engineering what you just finished. Otherwise, the numbers don't match. And that's a critical thing to think about. That's the purpose of re-engineering. And the example is this type 2 dimension, this thing called descriptors in a star schema. A type 2 dimension, for those of you that may not know, is basically a historical record of a business concept focused around a particular business key. So it has everything in it. Like if you've got a PeopleSoft record for customer, your type 2 dimension for that might have 300 fields in it. Everything from the salesperson to the region to the customer itself and the customer householding details and on and on and on. So when you bring in another system to add to that customer dimension, you have to re-engineer all the load cycles to make sure the numbers line up in the fact table back in history. And this is where some of the complexity comes in, some of the brittleness comes in, and it gets tougher and tougher and tougher to do. The more systems you add to this, the more complex it gets. Eventually it falls over. So re-engineering can't be done. It gets stagnant and unmovable. And this is where the data vault model doesn't do that, doesn't box you into this. It allows you to incrementally add on bits and pieces. So that's the one thing I wanted to talk about there. The other thing that I wanted to mention is the data vault model enough? The data vault model is not enough. You can have the best blueprints in the world, but if you don't have workers that understand how to execute the blueprints or implement the blueprints, you're still not going to be able to build the high-rise building, right? So this is the analogy. If you hire a concrete expert to do the electrical, do you think it's going to get done right in a 50-story building? Do you think the wires are going to be laid right? Do you think if they don't have that expertise, are they the right person to put in that position? If you hire an electrician to lay the concrete foundation for your 50-story building, do you think the concrete for that 50-story building is going to be built properly? If they don't have the expertise, they shouldn't be building the foundation. And then, of course, if you don't hire anyone, you can have the best blueprint in the world sitting on your desk. But until you actually hire someone to implement, to apply a methodology for building with standards and repeatable processes and everything else, it's just a piece of paper called a blueprint on your desk. And that's my point. The Data Vault model is just that. It's a blueprint design for what you want to do. Without the methodology, you don't know how to build it properly. You don't know what the standards are that would turn it into a success. You really got to consider the model, the methodology, and the architecture. They all work together to achieve an enterprise solution. And this is really what's at the heart of Data Vault 2.0. CDV-DM, Certified Data Vault Data Modeler. It's a great certification. However, it's not enough. It just basically says the person understands the model. It doesn't cover the methodology. It won't cover the methodology. It doesn't cover the architecture. It doesn't cover the standards, the repeatability, the best practices, the patterns, the design implementations. And this is why we moved on to the practitioner certification and why we have the Data Vault 2.0 standards.
The model really, to me, it's optimized to support the methodology and the architecture, which are really the foundations of the Data Vault implementation. Without methodology, you don't have your implementation guidelines. That's the other piece. Implementation, how do you actually build this solution out? Naming conventions and the how-to pieces of things on the model and the processes, all of that are foundational. And the model is simply an optimized technique for ensuring that those other pieces actually flow together the way they're supposed to and are scalable and not having to re-engineer even at the model level. So just like Bill says, a school of fish does not a whale make. Hubs, links, and satellites does not a data vault make. It really is critical to understand that methodology and architecture are at the heart of the solution, along with implementation is a part of the methodology and the model. The three of those things all fit together nicely. So thank you to our audience. Thank you, Dan, for addressing these things. And I am looking forward to our next podcast.
So am I. Thank you, Cindi. Take care, everybody. We'll see you next time.